This is a man-made motor, a motor so small that more than 6,000 of them would fit on the head of a pin. Welcome to the world of the nanometer, a unit of measure that is 1/billionth of a meter.
A nanometer is pretty small. One of the best analogies that I like to use is to compare it with a human hair. If you take a hair off of the top of your head, you can see that it's very thin. And now if you take something that's 100,000 times thinner than that, that's a nanometer.
The ability to observe and construct things this small is at the heart of nanotechnology. And what scientists have discovered is that at the nanometer scale, everyday materials start to act in unimaginable ways. For Jeffrey Grossman, a UC Berkeley nanoscientist working with the National Science Foundation, that's exactly the draw.
The behavior of nanomaterials changes, or can change, when the size becomes so small when compared with a larger amount of that same material. When you have things that sort of start changing the way they behave, and now you have the ability to control that, it sort of opens up an entirely new phase space of material.
Suddenly it's like the periodic table projects out into a new dimension. It's not just that we have the list of elements, it's where we can change their sizes, and each size is a little bit different than every other when it's very, very small.
Nanotechnology has allowed us to create new materials, such as carbon nanotubes and buckyballs, which are both fullerenes. Nanoparticles such as quantum dots have also been developed. These nanomaterials are often better than traditional materials since they not only have a lighter weight, but also have a higher strength and durability. Carbon nanotubes, for example, are 6 times lighter and 100 times stronger than steel. With this technology, we will be able to greatly improve the efficiency of energy absorbing and storing products. Nanomaterials will enable environmentally friendly batteries with higher contents, or supercapacitors with higher rates of charging. Nanorods, nanoparticles, and nanowires have been used to improve the collection of charge in solar cells, and to drastically downsize the cells, making them more efficient. New catalysts consisting of carbon and noble metal nanoparticles created by nanotechnology will greatly improve the efficiency of hydrogen-powered fuel cells, overall lowering the dependence on fossil fuels. Nanotechnology will even bring us a world with complete manufacturing efficiency. Everything will be built out of individual atoms by nanofactories, and excess material will no longer be wasted. And that's not the only way nanotechnology is improving the environment. Nanotechnology is also remediating the environment, that is, removing contaminants. 2 examples of this are improving water filtration by using nanofiltration membranes, and reducing air pollution, which is done in many ways. One main method is to use nanomembranes, similar to those being used for water filtration, and another is to create catalysts that convert unwanted molecules such as greenhouse gases into harmless or useful molecules. Scientists at UCLA have also created carbon dioxide absorbing nanocrystals, and these are only a few examples. Nanotechnology will allow us to create smart drugs that are catered to each specific person and their illness without producing the side effects of current medications. The personalization of smart drugs means they are also much more effective and efficient than regular drugs. Right now, research in this field is focused towards bone repair, tissue regeneration, and cures for terminal diseases. Even cancer could be cured using this technology. One possibility is in nanovectors, which are man-made carriers used to help the transport of cancer-killing drugs directly to the cancer site in patients. There is a large number of possible nanomaterials that can be used as nanovectors, including fullerenes, but this is a topic too broad for this video. However, there is one disadvantage. With the advent and widespread use of nanotechnology, many jobs will be lost. This ranges from traditional farming, to the manufacturing industry, and even to insurance companies. Nanotechnology is being used to create smaller, more powerful, and more efficient computers at cheaper and cheaper prices. This means that it is easy to replace what the industry will sadly view as inefficient, mistake-making, and salary-dependent humans with computers.